Okay, we're gonna do three things. Find intervals in which the function is increasing or decreasing. This is essentially find x such that this is true, right? So this is going to tell you whether it's where it's increasing. If I know where it's increasing, I automatically know where it's decreasing. So let's first find the derivative. You get 2 cosine of x times by minus sine of x. This is by chain rule, right? There's two functions here, squaring and the cosine. Minus 2 cosine of x. Okay, let's factor out what's common. What's common is the minus 2 cosine of x. Okay, minus 2 cosine of x here, minus 2 cosine x here, and you get a sine of x plus 1. Okay, so you know what? Let's get rid of this negative. That's confusing me. I can just multiply both sides by -1. Okay, and get 2 cosine of x, sine of x plus 1. Where is that negative? So wherever this is negative, the product is negative, the first derivative is increasing. Okay, so let's draw cosine of x. Okay, right there. This one here, I would like to know when this is positive, for example. Okay, it's positive when sine of x is greater than -1. But that's pretty much always, isn't it? Sine of x, it looks like that. Here's -1. It's always bigger than -1. The only place it's not bigger than -1 is at this one x value. 3 pi over 2. You guys agree? 3 pi over 2. So from this condition, right? From that condition, it's actually everything. So we gotta say everything from 0. Well, we can just say this. Everything from 0 to pi, just omit 3 pi over 2. Okay, what about here? When this is positive, this must be negative, right? I'm sorry, this also must be positive. Sorry, I said that backwards.
Yeah.
If this is positive, this must be negative so that the product is negative. So where is it negative? Right here. Okay, so let me draw that on a number line. So right now we have from 0 to 2 pi, we can essentially be everything except for 3 pi over 2. So I'm going to omit that. Here's my picture, number line. Here, to be negative, it's only from pi over 2, right, to 3 pi over 2. So here's pi over 2. So we're talking about this, right? What's overlapping between the two regions? Only pi over 2, including pi over 2. Okay, but not including 3 pi over 2, right? So what that means is that when x is between pi over 2 but less than 3 pi over 2, function is increasing. That's what it means. Okay? Which means when x is less than pi over 2 or when x is greater than 3 pi over 2, okay, so this, because we're restricted from 0 to 2 pi, we gotta say greater than 0 here, and we actually have to say x is less than equal to, so equal to, its function is decreasing. Okay, decreasing. So we just answered part A now. So next, part B is critical numbers, right? That's very easy. It's these two. Okay, we already found that something is happening here. The sign changes, right? If you were to solve this equation here for equal to 0, we would have gotten, okay, x is pi over 2, and 3 pi over 2. These are critical numbers. Okay, here. So he says to find local max and local minimum. Okay, look. The question is, at pi over 2, what's happening? So here's pi over 2. And here's 3 pi over 2. So see, this is confusing to read, right? So usually we like to use a box. Okay, so the two critical numbers are pi over 2 and 3 pi over 2. This box represents the same information that's given here. Here's our first derivative. We just discovered, right? We just discovered that it's 0 here. These are critical numbers. Before pi over 2, right here, do you see that it's negative? It's decreasing. In between, it's positive. Greater than 3 pi over 2, up to 2 pi, it's positive, right? It's going down, up, right? Or sorry, it's going down, up, and then this is down again, right? This is a local minimum. This is a local maximum. I like writing in this box better because I can see it right away, that where's local max and local minimum. Okay, so that's the location. We actually have to find it. So for local max and minimum, we actually have to plug in f at pi over 2. So what's cosine of pi over 2? 0. Okay, this is going to be 1. So it's negative 2. This is, right, so at pi over 2 and negative 2, this is a local minimum. 3 pi over 2. What's cosine of 3 pi over 2? Still 0. 0. Good. What about sine?
Just 2.
It's actually negative 1, so it's going to be positive 2. So at 3 pi over 2 and 2, this is a local maximum. Okay. One final thing. We gotta find the interval of concavity. Okay, so this was the first derivative. Let's find the second derivative for concavity. Okay, so keep the minus 2 outside. Differentiate that, you get minus sine times by sine of x plus 1 plus cosine of x. Differentiate this and you get another cosine of x. You get minus sine squared x minus sine of x plus cosine squared x. So we have here a cosine squared x minus sine squared x. If you can remember here, actually, how do we solve this? We got to actually find out where this is equal to 0, right? For inflection points, or for concavity, right? So let's say I want to know when this is positive. The problem here is we have sine and cosine. True? You can't solve it for inequality like this.
Well, if you factor out.
Okay, so what we want to do is we got to change everything into sine or turn everything into cosine. But this one cannot be converted into cosine, so let's change that into sine. Okay. So, do you see there's lots of negatives in there? Let me factor out a negative and multiply to the outside. You get positive 2. You're going to get 2 sine squared x, positive sine of x, and minus 1. Okay, this factors. 2 times 2 sine of x minus 1, sine of x plus 1. Okay, again, either they both need to be positive or they both need to be negative to be positive, right? However, see this? Sine of x plus 1, this is always going to be positive, except where? We just did this. Right, so basically, from this one, right, we have that picture again, from 0 to 2 pi. Right, it's everything in there except for this one, 3 pi over 2. Okay, so everything in here. What about this? When is sine of x minus 1? So this is guaranteed to be positive now. So I got to make sure this is positive. Right? This is positive, which means sine of x needs to be greater than half. So let's look at the sine graph. Where is it greater than half? Here's half. Do you see that it's only from here to here? We know these x values. This is going to be pi over 6. And this is going to be 5 pi over 6. That's right. So we have to overlap this region with a pi over 6 and 5 pi over 6, which means the answer is only going to be this. So in the interval when x is between pi over 6 and 5 pi over 6, it's concaving up. Okay, concaving up. When it's from 0 to okay, actually you don't include the pi over 6. They're actually inflection points. Okay, up to there, or from pi over 6 all the way up to 3 pi over 2, or this is kind of a lot to write, 2 pi. This is concaving down. Your teachers might be happy with just saying everywhere else is concaving down. Okay, so David asked, how come it's including 0 here, right? How come it's including 0? Now the inflection points that we got are only essentially the critical numbers from here, and they were strictly pi over 6, 5 pi over 6, and the 3 pi over 2, right? So there is no inflection point at 0, right? That must mean, okay, since it's only concaving up in this region at 0, right? Even though we cut the picture off at 0, at the moment of 0 it's still concaving down. Okay, so we're talking about the original question. So this one right here, this function here, right, is going to be concaving down, right, at 0. You only have to exclude the inflection points, not the other points. Okay, you know what? That means actually I should include 2 pi here too.